Aldehydes and ketones. Unit 12 is aldehyde, ketones, and carboxylic acids. It is mainly divided into two different sections. In one which we are going to do aldehydes and ketones, and the other one is going to be carboxylic acids. So part A and part B. When we look at the entire chapter, we are going to discuss nomenclature, nature of carbonyl group which is present, methods of preparation, physical and chemical properties, and the mechanism, and the reactions, nucleophilic reactions. Okay, and the second is uh, nucleophilic addition reaction, and aldol condensation. These are very important reactions of aldehydes and ketones. And similarly, we will discuss same things in carboxylic acids nomenclature. Okay, how it is prepared. So aldehydes and ketones, they are going to consist of the functional group C double bond O. This group is known as carbonyl group. In case of aldehydes, it is seen that one alkyl group is attached to the carbonyl group. And in case of ketones, there are going to be two alkyl groups which are attached to the carbon atoms. This will be the difference between aldehyde and ketones. In aldehyde, we will have one alkyl groups, and ketones, we will have two alkyl groups. They may be same or different. These play important role in biochemical process. Because of their very good aroma, they are used in the synthetic materials in the perfume industries, because they have a very significant kind of aroma. For example, we are talking of cinnamon. This cinnamon is extracted from cinnamon. Similarly, we have another chemical which is known as vanillin. Vanilla essence, which is generally used in bakery and ice creams and all. That has a very sweet smell. Okay. These are used in many food products. Okay. Synthetic materials like perfumes, fabric, polymers. And adhesive also. Now first, aldehyde. Aldehydes. They are also known as alkenyls. They have general formula RCHO. These are aldehydes. Second is ketone. These are also known as alkanones. and their journal formula. Now third we have carboxylic acids. These are going to be known as alkanoic acids. Alkanoic acids. And they have journal formula. Then we have acid derivatives. These are derivatives. They are going to be derived from carboxylic acids. First one are acyl halides. Here that OH has been replaced by the halogen. So they are known as acyl halides. Then the second one which we have is here the OH group is substituted by NH2 group. Then third we have esters. In esters, OH has been substituted by OR. And the fourth we have is anhydrides. These are formed by the loss of one water molecule, okay, from two molecules or any kind of acid. This is going to have the general formula of R C double bond O O C double bond O R. These are going to be anhydrides, which are formed by the loss of water molecule. As an example, we are taking the acetic acid. We are taking two molecules. So one molecule of water is lost. The anhydride which is formed over here is known as acetic anhydride. Now we will read the electronic structure of carbonyl group. Electronic structure. When we look at the electronic structure, we have C double bond O, which is one pi bond, and other is going to be sigma. This carbon oxygen bond here the oxygen over here is going to be highly electronegative, as a result of which it is going to attract shared pair of electrons. It will give it partial negative charge, and carbon is going to have partial positive charge. In case of carbon-carbon double bond, this kind of characteristic cannot be seen because of the same electronegativity of the both elements. The bond is going to become polar and it is going to be resonantly stabilized. If we see the resonating structures of this particular bond, Because of this positive and negative charge, because of the polarity of this bond, that is going to make carbonyl group highly reactive. So let's now start the nomenclature. How do we name the aldehydes and ketones? First, we are going to do common system. According to the common system, when we are going to do a nomenclature of aldehydes, the first will be the derivative of this is going to be formaldehyde. And then the next member, CH3, CHO, this is going to be acetaldehyde. If we are having 3 carbon atoms, this is known as propionaldehyde. Propionaldehyde. Then we have compound of the type this is going to be alpha carbon atom. This is going to be according to the alpha carbon atom. Okay, this is going to be known as alpha chloro propionaldehyde. Alpha chloropropionaldehyde. This is the common system. Now we will do IUPAC system. IUPAC system. In this case, the secondary suffix we are going to use is al. AL. Suppose we have HCH double bond O, only one carbon atom. This will be methanol. If two carbon atoms present, the root word will be it, a, null. If we are going to name CH3CH, CHO, Cl, this, it is terminal, it will be 1, it is 2 and 3. It is going to be 2, 2-fluoropropanol. Whenever CHO is present in the chain, it is always going to get number 1. Okay. Let's take an example. We have CH3, CH, CHO, CH2, CH2, CH3. So this is the type of compound given to you. Then, so we have 1, 2, 3, 4, and 5. This will always given 1. So the name will be 2-methyl pentanol. This is the IUPAC system of nomenclature of aldehydes. Now IUPAC, now the nomenclature of ketones. ketones. If we have CH3O CH3, in this case, both the alkyl groups are same. So this is going to be known as simple ketone, symmetrical ketone. If both the alkyl groups are same, they are known as symmetrical ketone or simple ketone. If we go through the common system of nomenclature, two methyl groups are present. We can name it, can be named as dimethyl ketone. This is the common system of naming the ketone. Similarly, C2H5 or C2H5, this is going to be known as diethyl ketone. If we are having different alkyl groups like CH3, CO, C2, this is known as unsymmetrical ketone or mixed ketone. So here we will going to name them alphabetically. This is going to be known as methyl ketone. Methyl ketone. Now we will see IUPAC name. We will write down the root word plus ane minus E plus on. If you're looking at the first member of ketones, it will have 3 carbon atoms. This is the first member. The minimum number of carbon atoms which can be present is 3. Less than 3 cannot be present in ketones. According to 3 carbon atoms, it is going to be propane minus E plus on. Propanone. So the name will be propanone. यहाँ पे एम का जो ई है उसको हमने रिमूव कर दिया है. If in case there is an unsymmetrical ketone present, in this, the lowest number to the ketones, okay, 1, 2, 3, and 4. The name will be butane 2-O. We have CH3, CH2, CO, CH2, CH3. 1, 2, 3, 4, 5. So this will be pentane 3-on. Pentane 3-on. So this is the compound we have. The numbering of the chain will start from here. 1, 2, 3, 4, 5, 6. It is going to be 2-methyl hexane 3-one. So this is the IUPAC method of naming. Now isomerism. Having same molecular formula but different structural formula. Okay. Aldehydes. Isomerism in aldehyde. The first time of isomerism it shows is chain isomerism. Molecular formula is going to be same, but chain is going to be different. CH3, CH2, CH3, CHO. This is butanol. अगर हम इसको ब्रांचिंग करेंगे then we will have this will be 2-methyl propanol. Now we have functional isomerism. In case of functional isomerism, the molecular formula is going to be same, but the functional group is going to be different. If we have CH3, CH2, CHO. CH2OH. They have same molecular formula but different functional group. Then we are taking another example. This is butanol. Its isomer is going to be CH3CO CH2 CH3. Next type of isomerism is tautomerism. It is simultaneous shifting of hydrogen and bi-electron cloud. This is acetaldehyde. Over here, the double bond is going to shift over here, and what is going to shift towards the oxygen. The tautomer which we are going to have will be CH2 double bond COH and H. This is known as vinyl alcohol. It is also it is going to be alpha hydrogen which is going to participate in tautomerism. Beta cannot participate, only alpha can participate. Let's take this another example. CH3, CH2, C, double bond O, H. It will be alpha. So here we will get CH3, CH, double bond C, OH, and H. And this will be propanol. And इसका UPSC name होगा 1, 2, and 3. Propanol. Both of these are going to be tautomers of each other. Now, isomerism of ketones. Tautomerism. And this is known as ketoenol tautomerism. This is the alpha. This will shift over here and double bond will shift over here such that we have CH2 double bond C OH CH3. This is known as keto form. This is known as enol because it contains ene and all together. So it is known as enol. Keto, and this is known as ketoenol tautomerism. Metamerism. Metamerism. Ketone is non-terminal functional group. The number of carbon atoms in both sides can be different. That is going to give the origin of metamerism. Carbon atoms of both the keto groups. The carbon atom on both sides of the keto group is different. That is metamerism, which means that we have CH3, CH2, C double bond O, CH2, CH3. Here are two carbon atoms on the left hand side and a carbon atom on the right hand side. The metamer of this will be here one carbon atom on the left hand side and 3 carbon atoms on the right hand side. This is also known as position isomerism. But in ketones, we name them metamerism.